welcome to episode 2 of Battleships. Last episode, we started work on our one-player version of Battleships. We got some input from our user, we turned it into some coordinates, and we rendered our first version of the board. This time, we're going to start looking at the actual battleships themselves. We're going to think about how we might represent them in code, and then we'll print a different board that just has the battleships visible. I've written us our little milestones. Exactly what I said. Decide how to represent the battleships in code and then render them. Before we think about how to represent battleships in code, let's think about what a battleship actually, what it means to be a battleship. You have a location of some sort. So remember, in battleships, a battleship is something that spans multiple squares. It might be horizontal like this, or it might be, how can we do this? How about like that? It might be vertical like that. And I think they're usually between 2 and 5 squares long. So it has a location. You could say it has a length as well. And then it also has arguably a health. I'm not sure if that's the right word for it. We'll think of something better. But whether or not it's been hit. For now, we don't really need to worry about its health because we're not combining it with shots for now. But it is always good to keep in mind what's coming in your program. It's always important to balance what it is you're trying to achieve right now with what you know you're going to be trying to achieve shortly. But for now, let's just think about how to represent a battle's location and a battleship's location and its length. There are several ways we could do this, actually. We could represent the battleship as just a list of coordinates like this. So it would be something like that. That would be a battleship with length 2 that spans these 2 coordinates. Another way to think about a battleship is that it has a head location, which is like one end of the battleship, and then it has its length. So for example, this would be, for our version, it would be 1, 1, and then a length, which would be 2, an integer, 1, 1, and then a direction or sort of an orientation that it's pointing in. So for our battleship here, if you think about it, it's actually going to have to be pointing up, or maybe let's think of it as north. These are these describe the exact same concept, and we could use either of them. Both of them would make sense. I think let's actually kind of use both, and I'll show you what I mean by that. And another thing I want to come back to, which I think is a little bit interesting, is why I prefer to use north than up. We'll talk about that in 1 second. So because a battleship is a relatively sort of complex concept. It has this location and its length, and it's going to have this idea of a health, and maybe some other stuff. We'll see. I think it would be nice if we represented it using a class. We don't have to use a class here. You never have to use classes, but a battleship is an object. It's a thing, and so it makes sense to represent it using a class. And I said that we're going to use a combination of these two things, and I'll show you what I mean. So internally, we're going to represent the battleship by the first method. It's going to take in this 1, 1 and this 1, 0, these coordinates. Maybe let's call it body, actually. And I quite like that because it means it's going to be quite easy for us to say, for example, has this shot hit this battleship? We'll just say, is the coordinate of the shot in this list of body coordinates that we've got here? However, it's going to be kind of fiddly if whenever we want to create a new battleship, we have to think about what its coordinates should be. I think it's easier to think about it in code in this form, but maybe easier to think about it in your head in this form. I think I would certainly rather say, give me a battleship that starts at 1, 1, of length 2, and then points north. I think that's easier to think about. So let's make the way that we construct a battleship by have it where we pass in the head, the length, and the direction, and then we're going to convert these into a body. So that means, we'll come back to what this static method thing means if you haven't seen it before. What that means is that we'll say our battleship is going to be a battleship.build 1 to north. And that's kind of a nice little syntax. And especially, let's pretend it was 5 long and say it was pointing south. We could, this is actually equally valid, we completely have the option of doing this, of also saying that battleship, we can use instead of using our build helper method, we could just use the direct constructor here where you give it a body. We could say it's at 1 1, and then if it's pointing south, it's going to be 2 1, 3 1, 4 1, 5 1. These mean exactly the same things. This battleship here and this battleship here are identical. But this just looks to me so much easier for a person to think about, this first one. And also, say what happened if we wanted to, actually let's move it to 1 2. That's a single change. Whereas here, we'd have to change each of these individually and just hope we didn't get any of them wrong. So we're using this as the internal representation, but this as the way to create them. And what this static method thing does is it just turns this build into a method that you call on the class. So you go battleship with a capital B dot build, and it's going to return you a new battleship. Whereas methods without static method, they are methods that you call on an instance of the class. So this would mean, it wouldn't make any sense, but this would mean you would create a battleship and then called build on it, which doesn't really make sense. So we use static method. Our next task is to figure out how to go from the head, the length, and the direction to this list of coordinates. I suspect we're going to sort of do the standard thing where we start with an empty array, an empty list here, and then we're going to iterate through in some way and add each coordinate that we generate to this body. And we're going to want to iterate through for each unit of length. So if length is 2, we're going to want to add 2 elements to the body. And if it's 5, we're going to want to add 5 elements to the body. And it's fairly obvious what we're going to do at first. Well, maybe not. Let's have a look at this in a bit more detail, what we're going to do. If this is, say this is the head here, we're going to look at the direction, and then for each time we pass through this loop, we're going to take 1 step in that direction. So say our direction is east, we're going to want to take 1 step going east, and then add these coordinates to our body. Then another step, add these coordinates, then another one and another one. And this variable I, this counting variable, is going to represent how many steps we've taken. So let's see what happens if we're going north. And we'll come back to why I like the north-south, east-west distinction, or way of specifying directions. Then the element that we're going to add is going to be, it's the head, and so this is the x coordinate we're generating now. It's going to be the head's x coordinate, and because we're going north, which is up, that doesn't actually change the x coordinate at all. So the x coordinate of every element in our body is going to be the same as the x coordinate of the head. However, the y coordinate is going to be the y coordinate of the head minus I. So minus 1 for each time we've been through this loop. And it's minus, remember, not plus, because if you think back to how we drew our board, we said that up in this corner is the 0, 0 coordinate, up in the top left. So every time you take a step north, you're going closer to 0, and so that's reducing your y coordinate by 1, which is why this is a minus sign. Going south is very similar, except it's a plus, there we go, because every time you go south, your y coordinate increases by 1. If you're going west, then it's the same thing, but reversed. So the y coordinate, when you go east and west, the y coordinate stays the same because you're going along the same row, and it's just the x coordinate that changes. If we're going west, that's going this way. That's going, again, going closer to the 0, 0, which means we subtract 1. So we subtract for each step we've taken. And then by a process of elimination, or just logic, we can see that this must be plus. Then we want to append our element to the body each time we go through, and then return the body. And that's it. Nope, sorry. We don't return the body. We return a battleship that contains, that is constructed from the body. So this is a very simple class for now. And you could argue that it shouldn't even, as I said, we don't have to make it a class. If this was the only, here we go. If body was the only property that a battleship was going to have, then yeah, we wouldn't want to wrap it in a class. There's almost certainly no point wrapping just this single property in a class when the array of coordinates on its own would be good enough. But because we know we've got our health and where it's been hit coming as well, and also just for practice, let's wrap it in a class anyway. Right. Now let's make some battleships down here. Let's do it above all our testing. Oh, sorry, all of the rest of our codes, because we don't want to have to run that as well. So at the start of the game, we need to generate some battleships. And we might allow, once we have our full game, we might allow our players to specify them, perhaps using this head, length, direction syntax. But for now, let's just hard code some ourselves. So let's use this one over there that we build. So it's 1, 1, length 2, heading north. Oh, I didn't talk about why I think north, south, east, west is good. The reason I think it's good, rather than up, down, left, right, is if we had up to represent going up, I just think it'd be a bit confusing that as you go up, the y coordinate decreases. Just whenever I think of up, I would normally imagine a number increasing. And when I go down, I'd imagine a number decreasing. So all else being equal, I think it's better to use north, south, east, west that doesn't have that connotation. You could absolutely use up, down, left, right if you wanted. It would completely work. But I think north, south, east, west might be slightly more less ambiguous, at least. Let's make some more battleships over here. Let's start one at 5, 8. And I've got to make sure we don't go off the board. Let's have a 5 going south. Then let's have one going side to side. 2, 4. 2, 3. Let's make it length 4, going to the east. In the same way as our shots data structure is a list of coordinates, our battleships is a list of battleships. Let's just see what happens. We'll put an exit here so we don't have to run the rest of our program. This won't really tell us anything interesting, apart from display all the syntax errors I made. Line 47. Oh, I just didn't put any commas in my list. And also, I can see this is battleship. Nice. And we can't see anything about the battleship, but we can see that they're there. In fact, let's go through them and print their bodies. No, don't need the parens. This looks good. This is not what I was hoping for actually, because this is going to go off the edge of our board, and I thought I'd made it so they wouldn't. So we'll have a closer look at that one. And this one is going east, so we expect the X's to be going up, and they are. South, yes, okay. This should go north, because again, remember, south increases the y-axis number, whereas north decreases it. If we run it again, great. They're all within our 10 by 10 board. I think we can give, I think we can give ourselves a tick. We decided how to represent battleships in code. Now we can render the battleships. At some point, we're going to probably want to figure out some way to combine rendering battleships with rendering shots, and maybe render shots differently if they're on target and things like that. For now, maybe just for practice, and also to help us debug, and also I'm sure this work will turn out to be useful as well. Let's just make a separate, completely separate render method for battleships. And now, instead of shots, as we had on our render method, we just want to pass in our array of battleships. So some pieces of this are going to be the same. We're going to want the same header. And actually that's it. That's the only thing that's the same. Rendering battleships is a bit harder than rendering shots, because shots just have a single coordinate. A shot is either there or it's not. A battleship is rather larger. It expands over several squares. And what we could do, one approach would be, let's go back to our Scratch file, is to combine all of the bodies into one big long list of all of the coordinates that contain a battleship, and then do exactly the same thing as we did here. Just say, is this coordinate in our big long list of all of the coordinates for battleships? If yes, print whatever, an O, otherwise print a space. And that would be okay, that would work, but I want to leave the door open to some other functionality. I want just to leave the door open to printing boats differently depending on how big they are. So rather than just having it being a big there we go. Yeah, that looks nice. Rather than just having it being a big blob of zeros, or O's, sorry, where you can't really tell what ship is part of what, I think it's cool if we were able to print them something like this. We won't do that now because we want to keep things simple and maybe come back later and add these bells and whistles. But I think it's worthwhile easily leaving ourselves the opportunity to do this. It would also be completely defensible, by the way, to take this approach. Everything is wrapped up inside this render battleships function, and we can change how this function works without having to change the rest of our code, which is, again, a nice property of this approach of separating out everything from everything else. The way I think we should do this then is we're going to use a 2D list. And a 2D list, if you haven't come across one before, is a list where each element is itself another list. So consider, so let's say we wanted to represent a 3x3 grid. We might do that like this, where we have our outer list, which has 3 elements, and each element is itself a list, which contains 3 elements, which for now is just none because we haven't got anything on our board yet. And then if we want to access this, say we want to look at the coordinate like 2, 1, we would just go, we can access it in a very intuitive way. We can say give me the second column, which is 0, 1, 2. And then because that itself is also a list, we can look at that by applying the second index, 2, 1. And so that gives us a very nice intuitive data structure that we can use to construct our board. So we're going to start with our board being empty, where everything is none because we don't have anything on our board. Then we're going to go through our battleships, iterate it through each battleship, and add it onto our board. Let's see what that looks like. So first, we want to construct our empty board. We'll start with an empty list. And because this first coordinate looks at this outer list, we're going to want to iterate through the width first, because we want to access it where this first coordinate is the x and this is the y, because that's how coordinates are usually structured. So we want a number of elements in this outer list equal to the width. And then our row is going to be, well, we can actually do this slightly tersely. Let's do it the long way first, just to show you what I mean. So we'll do a similar thing to what we did here, where we construct our row, but now every time we go through here, we are going to append a none, and then at the end here, we can append our row onto our board. And let's just print the board and see what it looks like. It's going to not look remotely pleasant, but it will be useful for debugging. So we want to render battleships 10, 10, and battleships. Right, so we don't need that anymore, but you can see that it's printed this outer list, which has, I'm sure if you counted them, there are 10 sublists, and if you counted them, each of them has 10 nuns in it, which is exactly what we expected. So as I said, this is the slightly long-winded way of writing it. If we wanted to one-line this, we could do it like this. And this uses a Python syntax called a list comprehension. You can maybe, if you squint, see what it's doing. If we really wanted, we could do both of these in a list comprehension, which would be, I think, get a bit tricky to read, but it would be very terse. And we can get rid of all that code as well now. Now that we've done that, we're ready to populate our board with the things that we want with our battleships. So in order to do that, we just iterate through our battleships. Oh, sorry. Before I go on, I remember what I wanted to say. A nice little, what's it called? A finesse, I suppose, is if you look at our nested lists, nested for loops here, we don't actually ever use these x and y variables, counting variables. So we can actually replace them with underscores. And this is a feature found in many languages, and it just indicates that we don't use these variables. Again, it's not important, it's not essential, but it just indicates that if you're thinking, okay, well, maybe is x important? Where's x used? What's going on there? It's just saying, nope, nothing to see here. It's one of fewer things to think about for anyone else reading your code. Anyway, back to our battleships. We want to add the battleships to the board. So for each battleship, we then want to go for each element in that battleship's body and add that element onto the board. And by add it, I mean we want to set the element in our two-dimensional list corresponding to this element's position to, let's say an O for now. We can actually, similar to what we did down here with this sort of deconstruction syntax, we can actually do the same thing up here, which is another nice finesse. It just automatically splats out the two components of each coordinate into the x and y constituent parts. And that means that we can do board x, y is O. And now that we've constructed our board, and then we've changed it, we've added the different characters that we want to print to it. Well, let's quickly debug that. Int object is not iterable on line 51. What I've done there is, you might have noticed this yourself, I needed to wrap that in a range. List object is not callable. Oh, whoops. And what it means by that is that's not a method, it's just a property on the object. And this looks kind of plausible. There's a lot of nuns still, but you can see these O's floating around. So it looks about right. I'm optimistic that it's going to work. Now we can do the same thing. We're going through each row. We want to print our board row by row. So we're going to want to iterate through the y coordinates first. And of course I've made the same mistake that I did before. And then exactly the same as we did before. Well, no, we don't even need to do this. We can just do print. Let's see. Okay, this is slightly fancy. We've now got our row. We'll do it in longhand first, and then maybe we'll split it out a bit. Do we have a row? Oh no, we don't. Never mind. We will actually have to do roughly the same thing that we did before. So row is a list, and then we append onto our row our x and y, and then we print using the same syntax that we printed before. No, we don't need to print that. Oh, this should not be that, sorry, this should be board x, y. There's going to be a little bug here. See if you can spot it. Well, that wasn't what I was hoping for. Oh, actually, I suppose it is. Yes. Expected string instance none type found. And this is because the elements in board are either none or a character. So what we need to do is, if it's none, we want to append a space, just to represent nothing. That looks pretty great to me. The only thing we've missed, of course, is the pipes along the side. And the way we do that is same way as before, just a pipe and a plus, and then a plus and a pipe. And now everything should line up. Delightful. I'm just scanning it. It looks pretty plausible to me. We've got our 2 there, our 4 there, and our 5 going along there. So I think that's it. Do we have any tidy up that we need to do? Not really, it's already beautiful. So what we just did was figure out how we wanted to represent our battleships in code, hard-coded a few battleships in, and then rendered them out to the screen in ASCII art again, like this. Next time we're going to start to think about how to combine battleships with shots, because our player is shooting at the battleships, sometimes they hit, sometimes they miss, we need to tell them what they've done. That's going to come up next time. For now, We can get rid of the scratch file again. Sorry, I always use this. GS is just my little shortcut, my shorthand for git status. We can go git add dot to stage them, git commit, write a nice commit message. Episode 2, what did we do? Add battleship class and render battleships method. Pretty long, but describes what it's done. So I'll see you next time for when we start taking actual shots at actual battleships.